Here we have a turning point in the course where we start to talk about statistical inference. This is really the point of the course. Up to now, we have focused on this data collection idea. So this is what we've been doing, the idea of defining a sample or setting up a randomized experiment to get data about a sample. What we start doing going forward is this idea of statistical inference, where instead of going from a larger population to a sample and saying, what can we say about the sample, we now start to go in the other direction and say, suppose we have information about a sample, what can we now infer about the population? So we have a little bit of language that has come up already for the most part, but now with some terminology attached to it. We say that a parameter describes a distribution for a population. And the parameter is often unknown. So here we have a list of population parameters, and that a statistic describes a distribution for a sample, and generally we are able to calculate a statistic exactly. So we have a list here of sample statistics. The art of statistics is based on a sample statistic. What can we say about the population parameter that it represents? So you can see that we have a pairing here where x bar is the sample statistic for a mean. If we have information about x bar, what we're really interested in is information about mu. And similarly, if we have information about a sample standard deviation S, maybe what we're really interested in is the population standard deviation sigma, etc. So all of these have come up before. We use this p hat when we are talking about a proportion from a sample rather than a population. We use R for the correlation of a sample. We use, remember, this is the Greek letter rho when we're talking about correlation of a population. And we also have lowercase b for the slope of a regression line for a sample, and this here is the Greek letter beta for a whole population. So let's look at a few questions we might be interested in answering, identify the parameter that would really answer the question, and identify a sample statistic that we could use to help us answer the question. So if the question is, what is the mean wait time for northbound weekday morning traffic at Pleasant Valley and Riverside, at that intersection, then what we're interested in is a mean. So first we identify that mean wait time is a mean, and for this whole population of all northbound weekday morning traffic at this intersection, we're interested in mu. That's our population mean. What we might use to estimate that is if we're able to go out to that intersection and measure wait time for some sample of weekday mornings, then we have a sample that we can use to estimate mu. And since this is a sample mean we're talking about, we're going to call it x bar, and we'll fill in that description here. As you can see, I filled in just enough to make it clear what we're talking about, what the distinction is between mu and x bar. Of course, I still do mean mean wait time for northbound weekday morning traffic at this particular intersection. I just didn't want to repeat all that wording again. The real distinction between mu and x bar is that x bar is based on a sample of weekday mornings. So next we have the question, what is the correlation between outside temperature and hourly electricity demand in Austin? We see correlation here, and that's our clue about what parameter we want to use. The parameter we use to measure correlation of a population is rho, the Greek letter rho. Remember, this is the one that looks kind of like a P, but without the serifs and with the tail maybe swinging a little bit to the left just to make it stand out from that P a little bit more. So what we could do is look at a sample, right? And in this case, there's probably a few things that would make us cut down from our whole population. One of those might be that we don't want to look at every single energy customer in Austin, so we might just look at a sample of people. The other being that we, of course, can't look at this for all time, right? We can only look at it from a select time period. So we could either choose a time period or maybe even over a time window, choose a sample of months during that time window to create our sample. So let's try to describe this idea now in words. The letter we would use for a statistic that represents a sample correlation is R. So this is going to be the correlation based on a sample, which we will define as a sample of our customers and a sample of times. Now we could get more specific than this because, of course, if we were going to conduct this study, we would want to figure out what we mean by a sample of months. Do we define bounds on the earliest and latest, and how many are we going to choose, and are we going to choose them completely at random, or are we going to make sure that some are from summer and winter and spring, etc., and how we would choose our energy customers. But this is sufficient for now, since we're not actually doing the study or getting into more detail on the study. Going into this final question, how much difference is there in the proportion of 30 to 39-year-olds versus 50 to 59-year-olds on not having a landline, right? So we're really looking at a difference in proportions here. And it's not just one proportion, but two. So we want to think of that as being something we would write in terms of two parameters. So maybe we'll call one of them P sub 30 and the other P sub 50. And we'll just let that first number represent the whole range of 30 to 39 and the whole range of 50 to 59. So this is going to be estimated by a sample, right? We'll need a sample of 30 to 39-year-olds, and we'll also need a sample of 50 to 59-year-olds, or this could just come from a sample of adults in the US and we break them out by these age groups. But the letters that we use to estimate this, if we're talking about a proportion from a sample, we now call these P hat instead of P. So again, a lot of the details are implied here. We already have that we're interested in the proportion of 30 to 39-year-old US residents who have only a cell phone, and the same proportion of 50 to 59-year-old residents, right? Just indicating that we would take them from a sample instead of from the whole population of US residents.